long after closing the switch. T equal to 0, t equal to infinity is asking. So first let's go for just after closing the switch. Initially, will there be any possibility of any charge across the capacitor? Initial charge, is it possible? As this branch is open, so no question of any current flowing through the cell. So no question of any initial charge or initial current across the inductor. There's nothing like that. Agreed? So therefore, initial charge will not be there, that one. So based on that, it will be. So just after closing, so how the where all inductor is there, I'll replace with a open circuit. Then there's a resistor R3. Capacitor should be short circuit. Then this is a resistor R2 and this is R1. So how much of current will be there? So now what is the path of the current? So current, it will encounter these two resistors, they are in series. They're in series and they're shorted, no, here. So what is the effective? The current will in fact will flow only in this branch. I. So what is the current is asking? Current in R3 in the shown circuit. So where is R3? R3? No current will flow. So I is equal to E by R3. I is equal to E by R1. So let's keep it here. E by R1. And what is the current R3? Will be 0. So just after closing the switch is 0. I'll pick up this option. Next again, at t equal to infinity. At t equal to infinity. What I should do with inductor, where all inductor is there, I should replace with a short circuit. And where all capacitor there, there's an open circuit. Now, okay, this is R2. Check for any possibility of any current flowing through any path. So let's see the current here. There's a path available for the current to flow. And what will happen to R3? Look at the R3. It will be shorted, no, here. So the current will take path like this. No current will flow through R3, no also. So the current I. Here what happened? It is having a zero resistance path like this. No current will pass through R3. So now also what is I? I is equal to E by R1 only. This is
R1
not
plus
answered.
R2, sir.
R1 plus R2. Yeah. So shall I pick up? I'll give one more question. Then we'll wind up this numericals of this kind. Take the question. I'll draw the diagram. No use of such things practically, just for to trouble students in exam. All some what I am given, all these are meaningless questions. Practically no application. Why do I'll connect like this? Just only to check the students' ability to analyze things. Find the current through the cell at t equals 0 and at t equal to infinity. So straight away at t equals 0, where all inductor is there open circuit, where capacitor is short circuit. So here we have inductor, open circuit, capacitor, short circuit. Try to see no. So this will be one wire will come. Here this resistor R will be shorted. And this capacitor, what it will do? It will short all the resistors, no? Except this R. So what should be the current? Current will be only, current will flow like this here. There won't be any flow of current to this. So why can't current will branch? The current wants to branch. It's a short circuit path is available, no? So the current will take only this particular path. I. This will be shorted, no problem. So this will be shorted. You bring one short circuit here. This will be R by 2. R shorted and 3R by 2. And again, all these resistors what happen will be shorted by this wire. So current will be only I equal to E by R. Now similarly, let's go for at T equal to infinity. Where capacitor is there, so there should be open circuit. Where inductor is there, short circuit. Again, similar condition. So this will be shorted, no? This resistor will be shorted. Instead of resistor, they'll give bulb. So here's what the trouble starts. So bulb means, again, don't think anything. It's similar to resistor, no? Which bulb will glow, which bulb will not glow. The types of questions. So instead of resistor R, I can connect a bulb. I'll ask you which bulb will have maximum brightness, which will glow, which will not glow. So any best questions can be asked for you know. So again, the same problem. So the what all current is there will take the low resistance path. So there's a low resistance path available. The current, no current will flow in remaining other. This resistor will be shorted. This will be open. R by 2. 3R by 2 will come this one. So but still the effective. So I'll draw the circuit. So it will appear like this. If you simplify, this will be R by 2. Effective will be 3R by 2. Sorry, this R and this will be. So definitely this 3R by 2 also will be shorted. No, the same similar diagram will appear again for this. So what is the overall current? The current has to take path like this. Now you should not see like is asking object, you should not do like this. So I don't know some students what will happen for you in exam. They'll assume current here I1, I2, I3, I4, I5, I6, solve it, then put T equal to infinity or T equal to 0. Directly, basic idea, capacitor short circuit, inductor open circuit at T equals 0, T equal to infinity, capacitor open circuit, inductor short circuit, and carry on. No need of bringing mathematically here. I'll write expression for current through the cell at any time t. There I'll put T equal to 0. 1 hour, if they give time for this question alone, okay, think like that. Only 2-3 minutes, no, maximum you should wind up. Some questions, big circuit will be there. Just capacitor, inductor, replace with suitable equivalent diagram and get into the problem. At any time, if they ask you, okay, there's another way. But it's asking T equals 0, T equals 10. So straight away, replace with that suitable things and carry on. So at T equals 0, T equals infinity, the current through the cell will be same. So they'll ask you, what is the power dissipated by the cell? The moment switch is, the cell is switched on and after long time. It'll be same. E into I or E square R. Okay, now take this.